In the last lecture, we learned about event loops in Node.js, and we learned how event loop is responsible for executing asynchronous code in Node.js. We also learned about the 4 important phases of an event loop. So in the first phase of the event loop, the callback functions attached to expired timers get stored, and once the main thread is empty, those callbacks will be pushed to the main thread for their execution. In the second phase of the event loop, the callback functions attached to IO related tasks are stored. In the third phase of the event loop, the callback function attached to setImmediate function is stored. And in the fourth phase, all the close callbacks are stored. And apart from these 4 phases, these 4 callback queues, we also have 2 special type of callback queues. One is Microtask queue, where the callback function attached to a resolved promise gets stored. And then we also have this nextTick queue. And in this nextTick queue, the callback function attached to process.nextTick method gets stored. Now in this lecture, let's understand the execution of the callback function stored in a callback queue and their order in practice. Let's go to VS Code. And here, let's go ahead and let's first write 2 synchronous code. For that, I'm going to use this console.log statement because this console.log method gets executed synchronously. And here I will simply say program has started, and I will copy this line. I'll paste it here and I will say program has completed. Okay. Now, both these methods, both these line of code will be executed synchronously. Both these line of code will be executed in the main thread of Node.js. So if I save the changes, and here if I type nodemon space app.js, let's run this. So you can see program has started and program has completed. These 2 log messages has been logged here. Now let's write a timer function. So after this first console.log statement, I am going to use this setTimeout function. To this setTimeout function, first we need to pass a callback function. For that, I'm going to use the arrow function syntax. And in there, I will again use a console.log statement. And here we want to print the message, timer callback executed. Now this setTimeout function, it gets executed asynchronously. Let's also pass a time interval of maybe 0 milliseconds here. And since this setTimeout, it is a timer function, it will be executed in the first phase of the event loop. Right? That's what we have learned in our last lecture. The callback function attached to expired timers, they get stored in the callback queue of first phase of event loop. So here it is not executed in the first phase, it is stored in the first phase. So how this program will run is, when we run this Node.js program, first of all the top level codes will be executed. So in the top level code, first of all, this console.log statement will be executed. Then this setTimeout function will be executed. Now this setTimeout will be executed asynchronously. Okay, so it will run in the background. And since it is going to run in the background, it will not stop the execution of next line of code. It will not block the execution of next line of code. So this setTimeout function, it will execute in the background. And immediately after that, this console.log statement will be executed. Okay, so first we will see this message in the console, program has started. Then we will see this message in the console, program has completed. And once the execution of all the top level code is complete, then the event loop will start. And when the event loop will start, it will first go to the first phase of the event loop. Now in the first phase of the event loop, since here we have specified the time interval as 0, this setTimeout will expire immediately. And since it is going to expire immediately, this callback function will be pushed to the callback queue of first phase immediately. So once the execution of top level code is complete, the event loop will start. It will go to the first phase. In the first phase, it will find this callback function waiting for its execution. And since the main thread is empty now, because all the top level code has been executed already, the event loop will push this callback function to the main thread. And then in the main thread, this callback function will be executed. So the output will be something like program has started, program has completed, and timer callback has been executed. Okay, so if I save the changes here, that's what you will see. Program has started, program has completed. So the top level code were executed first and they were executed synchronously. After that, the event loop started. In the first phase, there was this callback function waiting for its execution. It was pushed to the main thread and the main thread then executed this callback function. And that's why we have this log message, timer callback executed. Okay. Now let's go ahead and let's add set immediate function. So this set immediate function is also a special type of timer function which gets executed immediately. Okay, this timer function expires immediately. And to this, we need to pass a callback function. Again, I'm going to use this arrow function syntax here. And in there, I will simply use another console.log statement. And in that console.log statement, I'll say set immediate callback executed. And to this set immediate, we don't need to pass any time interval because as the name says, it will expire immediately. And we have learned that the callback function attached to set immediate, it gets stored in the callback queue of third phase of event loop. So here, this callback function, it will be stored in the third phase of the event loop. So now when the program will start, again, first the top level code will be executed. That means this line of code and this line of code, it will be executed in the main thread. And once the execution of top level code is complete, that means once the main thread is empty, the event loop will start and the event loop will first go to the first phase. In the first phase, we have this callback function. So this will be pushed to the main thread from the callback queue of first phase and it will be executed in the main thread. Then the event loop will go to the second phase. In the second phase, we don't have any callback function because here in this program, we don't have written any IO related task. So we don't have any callback function related to IO related task. So that's why the second phase will be empty. So the event loop will now move to the third phase. In the third phase, the callback function attached to the set immediate, it is waiting, it is stored. So now this callback function will be pushed to the main thread and it will be executed. Now here is the catch. If you see, for the set timeout, we are passing the time interval as 0. And for the set immediate, we don't need to pass any timer value because it is going to expire immediately. So here in this example, both the set timeout function and the set immediate function, it is going to expire immediately. But according to Node.js documentation, the set immediate should always expire before any other timer. Alright, so in this example, according to Node.js documentation, this set immediate should expire before this set timeout. But that is not always the case. So this is a bug which is already known in Node.js. According to the documentation, this set immediate should always expire before any other timer. But that is not always the case, and this is a known bug. And because of that, you might see different order of execution for the callback function attached to set timeout and for the callback function attached to set immediate. And I will share a link in the description where you can learn more about this behavior. But for now, let's save the changes and let's see the output. If I save the changes here, so first of all, top level codes has been executed. That's okay. And then you will see that it says timer callback executed. So once the top level code has been executed, the event loop will start. It will go to the first phase. Since this set timeout is expiring immediately, this callback function is already pushed in the callback queue of first phase. And this callback function, it is waiting in the callback queue of third phase. So once the program has started, this line of code was executed, then this set timeout function was called. It will execute asynchronously, and once its execution is complete, that means once this timer is complete, it is going to push this callback function in the callback queue of first phase. So now this callback function is waiting in the callback queue of first phase. Then this line of code will be executed. Again, this set immediate runs asynchronously, and since it is going to expire immediately, this callback function will be pushed in the callback queue of third phase. Okay, and then this code will be executed. And in this code, we are displaying this message, program has completed. So you will see program has started and program has completed these two log messages first because these are top level code. So they will be executed in the main thread. And after that, the event loop will start. And once the event loop will start, the event loop will first go to the callback queue of first phase. There, this callback function is waiting for its execution. Okay, so this callback function will be pushed to the main thread and it will be executed, and this log message will be logged here. And then it will go to the second phase. Again, the second phase is empty because in this program we don't have any IO related task. Then it will immediately move to the third phase. In the third phase, this callback function is waiting for its execution. So it will be pushed to the main thread. In the main thread, this callback function will be executed and it is going to log this message. So this is the order of the output for this program. But if I go ahead and if I run this program again, if I save the changes again, we still see the same output. Let me save the changes again. And we are still seeing the same output. But sometimes you will notice that the order of these two outputs are interchanged. All right. Now let's add some IO related task here. So here I'm going to use this fs module. On that, I'm going to use this read file method. And again, this read file method runs asynchronously. Here we need to specify a file path. So what I'm going to do is I'm going to specify the file path of this input.txt. So it is in current folder, inside files folder, and in there we have input.txt. Okay, and then let's also pass a callback function. So this callback function will get executed once this read file method has finished reading all the content from this input.txt. Okay, in there let's add a console.log statement, and here let's say file read complete. So now what will happen? Again, when this program will run, first of all, top level codes will be executed. So the first output should be program has started, and the second output should be program has completed. Then, since the top level code has finished executing, the event loop will start, and the event loop will first go to the first phase. In the first phase, this callback function is waiting for its execution because here the time interval is 0 milliseconds, so it will expire immediately. So the third output should be timer callback executed. Then it will go to the second phase. In the second phase, the callback function attached to IO tasks are stored. So in our program, this read file is an IO task. And keep in mind that IO tasks are performance intensive. That means they're not going to complete their job immediately. They're going to take some time. For example, this read file method might take some time in reading this input.txt. So it is not going to finish its job immediately. And the callback function related to an IO task, that will be pushed to the callback queue of second phase only when the IO task has finished its job. In this case, when this read file method has finished reading all the content from this input.txt. Okay, so when the event loop will reach to the second phase, so the callback function related to this IO task, that will be stored in the callback queue of second phase. So by the time the event loop will reach to the second phase, by that time, this read file might not have completed its job. That means this callback function is not yet pushed to the callback queue of second phase. That means the second phase is still empty. So the event loop will move to the third phase. In the third phase, it will find this callback function because this set immediate, it will expire immediately. So this callback function will be pushed to the callback queue of third phase immediately. So in there, it will find this callback function and it will execute it. So the fourth output should be set immediate callback executed. Then the event loop will go to the fourth phase. In the fourth phase, we have closed callbacks. Here in this program, we don't have any closed callbacks. So the one tick of the event loop is complete. Now, the event loop will check if there is any other timer related tasks or IO related task waiting for its execution. And let's say by that time this read file has completed its job and it has pushed this callback function in the callback queue of second phase. So now in the second phase, there is a callback function related to an IO task is waiting for its execution. So now the event loop will start the next tick. In the next tick, it will first go to the first phase. In the first phase, we don't have any callback function to be executed. Then it will go to the second phase. And in the second phase, in the callback queue of the second phase, this callback function is waiting for its execution. So now this callback function will be pushed to the main thread and there it will be executed and it will log this message, file read complete. So first we should see these two log messages. Then we should see either this log message or this log message, depending on which one has expired first. And finally, in the last, we should see this log message. So this log message should always come in the last because this read file method is always going to take some time in reading the file. And once it has finished reading the file, then only this callback function will be pushed in the callback queue of second phase. So if I save the changes here, you see the first two synchronous tasks are executed. That means these two console.log statements are executed first. These are the top level codes. And once the top level code is executed completely, the main thread will be empty. And after that, the event loop will start. In the event loop, first it will go to the first phase. So in the first phase, this set timeout function is going to expire immediately. So that means this callback function will be pushed to the callback queue of first phase immediately. So this callback function will be executed, and we can see that message here, timer callback executed. Then it will go to the second phase. When it goes to the second phase, there the read file is still doing its job. Okay, that means this callback function has not been pushed to the callback queue of second phase yet. So now the event loop will move to the third phase. In the third phase, this callback function is waiting for its execution, so it will be pushed to the main thread. There it will be executed, and this message has been logged. And in the first phase, we don't have any callback function. The next tick will start. In the next tick, first phase is empty. In the second phase, let's say the read file has completed its job. So now this callback function is waiting for its execution. So this will be pushed to the main thread and it will be executed, and it is going to log this message, file read complete. Okay. Now let's take this program to another level. So what I'm going to do is I'm going to copy this code from here, or I will cut it from here, and I will paste it inside the callback function of this read file method. So after this console.log statement, let me paste this code, and I'm also going to copy this code from here. I will cut it from here, and again I will paste it after this set timeout function. Okay, now what will happen when we run this program? So again, when we run this program, first of all, the top level code will be executed. That means this console.log statement and this console.log statement will be executed. And now we don't have any other code in the top level. So now the event loop will start. When the event loop starts, first it will go to the first phase. Now at the top level, we don't have any timer related tasks, right? At the top level, we don't have any call to set timeout function or set interval function. So we don't have any code related to expired timers in the top level. That means the first phase is empty. Then the event loop will move to the second phase. Let's say by that time this read file has completed its job. So that means this callback function will be pushed to the callback queue of second phase. And since the event loop is in second phase, it is going to push this callback function in the main thread. And in the main thread, this callback function will be executed. So when this callback function will be executed, first it is going to log this message in the console. Okay, then it will go to the next line. In this line, we are calling this set timeout. And again, this set timeout is an asynchronous task. So it will execute in the background, and since the time interval here is 0 milliseconds, this set timeout will expire immediately, and this callback function will be pushed to the callback queue of first phase. Okay, then the next line of code will be executed. Here we are calling this set immediate, and since it is going to expire immediately, this callback function will be pushed to the callback queue of third phase. Now the execution of this callback function is complete. Then the event loop will move to the next phase, and the next phase is third phase. In the third phase, this callback function is waiting for its execution. So now this callback function will be pushed to the main thread, and this statement will be logged in the console. And once the execution of this callback function is complete, the event loop will move to the fourth phase. We don't have any closed callbacks, so the fourth phase is empty. Now the event loop will check if there is any timer or IO related task waiting for its execution. And yes, this callback function is waiting for its execution in the first phase of the event loop. So the next tick will start, and in the next tick, the event loop will go to the first phase and it will push this callback function in the main thread, and there it will be executed, and this callback function will be logged. So here the order of the output will be, first these two top level code statements will be logged, then this file read complete will be logged, then this set immediate callback executed will be logged, and finally this timer callback executed will be logged. Let's see that. Let's save the changes, and that's what you will see. So program has started, program has completed, then file read complete, so basically this log message, then set immediate callback executed, so this message, because from the second phase it moved to the third phase and it executed this callback function. And finally we have this timer callback executed, because this callback has been executed in the next tick. If I save the changes again, we should see the same output. All right. Now we also learned about some spatial callback queues. For example, the Microtask queue and process.nextTick queue. And we learned that Microtask queue or the process.nextTick queue, they don't belong to any phase. These are the special callback queues, and the callback functions stored in these callback queues gets executed immediately after the execution of the current phase is complete. Let's understand this with an example. So here I am going to call process.nextTick. Okay, and to this I'm going to pass a callback function. And in this callback function, let's simply use this console.log statement, and there let's say process.nextTick executed. Okay, process.nextTick callback executed. Now when we run this program, how it will be executed? Let's understand that. Again, first the top level codes will be executed in the main thread. So the first two outputs will be program has started and program has completed. Then the event loop will start. And in the event loop, first the event loop will go to the first phase. In the first phase, we don't have any callback function waiting for its execution. Why? Because in the top level code, we don't have any timer related tasks. Okay, so now it will move to the second phase. Now let's say when the event loop reaches to the second phase, by that time this read file has completed its job. That means this callback function is already pushed in the callback queue of second phase. So the event loop will push this callback function from the callback queue of second phase to the main thread for its execution. So there, the execution of this callback function will happen. This first line of code will be executed and it is going to log this message file read complete. Okay, then it will find this set timeout function. So since this function is going to be executed asynchronously and since it is expiring immediately, this callback function will be pushed to the callback queue of first phase. Okay, then it will move to the next line. There it will find this set immediate. Again, it is also going to expire immediately. So this callback function will be pushed to the callback queue of third phase. And then it will find this process.nextTick method. So this callback function will be pushed to the callback queue of process.nextTick. And in this way, the execution of this callback function is complete. Okay, now this callback function was stored in the callback queue of second phase. So which is the currently executing phase here? The currently executing phase here is the second phase. And we learned that once the execution of currently executing phase is complete, if there is any callback function in the Microtask queue or process.nextTick queue, that will be executed next. So when this callback function was executing, in there we pushed this callback function into the process.nextTick. So now after the execution of this callback function is complete, there is a callback function in process.nextTick queue which is waiting for its execution. And that callback function will be executed immediately after the execution of current phase. And the currently executing phase in our example is this second phase because this callback function was stored in the callback queue of second phase. So once the execution of current phase is complete, now the Node.js will check if there is any callback function waiting inside the Microtask queue or process.nextTick queue. And yes, we do have a callback function which is waiting in the callback queue of process.nextTick. So that will be executed next. Okay, so after the execution of this callback function, the callback function attached to process.nextTick will be executed. So the next output will be process.nextTick callback executed. And once this callback function is executed, then the event loop will move to the next phase. So now it was in second phase. Now it will move to the third phase. In the third phase, this callback function is waiting for its execution. So it will be executed and this message will be logged in the console. And after that, it will go to the fourth phase. The callback queue of fourth phase is empty. So now the event loop will check whether it has to start the next tick or not. And how the event loop checks that? It checks it by checking if there is any timer related callback or IO task related callback waiting for its execution in the callback queue. And yes, in our case, this callback function is waiting in the callback queue of first phase for its execution. So again, the next tick will start. In the next tick, the event loop will go to the first phase and it will execute this callback function. So the last output should be timer callback executed. After that, the second phase, third phase and fourth phase is empty. So now the event loop will exit. So if I save the changes now, first we should see these two log messages. Then we should see file read complete. And once the execution of this callback function is complete, the callback function related to process.nextTick will be executed. So the fourth output should be this. Then from the second phase, we are moving to the third phase. So in the third phase, we have this callback function. So the next output should be this. And finally, after that, this should be the last output. Let's see if that's the case. If I save the changes, that's what you will see here. So these two are the top level codes. Then file read complete because the second phase was the first to be executed, this line of code. Then we have process.nextTick executed because once the execution of the current phase was complete, the callback function attached to process.nextTick got executed. And then we have this output message set immediate callback executed because after the second phase, the event loop moved to the third phase. And in the third phase, we have this callback function which is logging this message. And finally, we have this message logged here, timer callback executed. That's because this callback was executed in the next tick. All right, now I know this lecture has been a bit lengthy, but I wanted to clear your concept related to the phases of an event loop. And I hope I have succeeded in that. But still, if you have any questions related to event loop or different phases of event loop or their execution order, you can surely put it in the comment section and I will try to answer it as soon as possible. This is all from this lecture. Thank you for listening and have a great day.